Hey everyone. So we only have 3 slides. I only thought we were allowed 3 slides, so it'll be pretty quick. We'll do mostly talking. So as you heard on a couple of these presentations, waste is a big problem. So New York City, of course, has a ton of waste here. But inside this waste is trapped some very valuable materials, byproducts, nutrients, etc. for agriculture. And one of the most abundant biopolymers in the world, cellulose and cellulose nanofibers, are also trapped inside this waste, that which is dumped into landfills. Until recently, it's been pretty expensive to extract these cellulose nanofibers into useful valorized products. All right, so which is this technology that we're commercializing that was created at Stony Brook University? We're essentially able to unlock nature by deconstructing this waste into its core components. So what our system does is it extracts any nutrients that are trapped inside of the waste. This is almost everything except cellulose nanofibers. And then we're able to take this cellulose, oxidize it into cellulose nanofibers, and then cross-link it and upcycle it or valorize it into different products. Right now, we're in mostly the agricultural industry because they have a waste problem and a need for the byproducts. So commercializing this with our partners over in Holland, Jiffy for substrates. Lately, we're partnering with to solve the manure industry. So manure management is a huge problem. I had no idea it was a big problem until I started working with them. But our system can cut down greenhouse gases dramatically by processing the manure instantly. And it's actually a perfect feedstock because the cow breaks down the waste for us, pre-breaks it down. So when it gets to our system, we're able to do like a flash process in about 3 minutes and convert it to these gels. So right now, you see here, we've got these gels that we use for hydroponic vertical farming and field growing. We also have like hydro seeding products. We can coat seeds, so we can make it hydrophobic or hydrophilic. We can actually coat urea with these cellulose nanofibers as well, so no synthetic byproducts at all. Those plugs you see over there is actually only about 1 to 2% cellulose, and the rest is water or nutrients mixed in there. So one banana peel can make about 6,000 plugs, because the cellulose nanofibers can go so far with this. And really, agriculture is the first real start to this. So there's a lot of industries that we can go into from here. So like I said, agriculture has a waste problem and a need for the byproducts, but we had projects where we took coffee grind waste and made it into hydrogels for cosmetics. We worked with the Army Corps of Engineers to increase strength of concrete. Medical, we've done superabsorbent polymers. So there's a lot of industries that we're going to get into in the future. Right now, we're working on scaling it up, which always has its challenges, but we're at the kilogram scale right now at Stony Brook's Advanced Energy Research Center. And right now, we're working with toll manufacturers to scale us from kilograms to tons to hundreds of tons, because there's a lot of waste out there that's just getting thrown into the landfills. And we have actually some of these gels. My colleagues over here, we got Dave, Samantha, and Quill. So Quill's got some of these plugs that he made a couple of days ago. If you guys want to meet us outside and chat some more, you can feel them and play around them. And that's it. Kind of flew through it quick. It's only 3 slides. I could take questions if you guys want. We can come chat outside. So thanks a lot, everyone.